A topic that I really struggled this year in OChem with was RNS naming with organic molecules. We name enantiomers as R or S configurations to distinguish between the non-equivalent configurations within stereogenic atoms. The molecule must be bearing 4 different groups to be considered to have an R or S configuration. This topic was challenging for me because I'm not very good at visualizing 3D objects in my head, so I was bad at being able to rotate these objects to determine whether they were R or S enantiomers. I attended many SI sessions on this topic, and our SI suggested that we use the hand rule, and initially this worked. However, whenever I would take a break from the material, I would forget how the hand rule worked, and the hand rule was heavily dependent on imagining the 3D objects in my head and rotating them, which I'm not very good at. So I decided to seek out other tutoring, and my tutor suggested using the method that is in the book. And this method starts with first assigning priority groups and then putting the lowest priority group in the back so that the priority groups of 1, 2, and 3 are facing you, just like I have arranged in these 2 examples. Another way to phrase this is by looking down the stereogenic atom toward the atom of lowest priority. That's how you can picture it as well. Once this can be visualized, we draw arrows leading in the direction of the highest priority group to the second highest priority group and then to the third priority group. If these arrows are connected in a counterclockwise direction, we say that the enantiomer is an S enantiomer. If the arrows are connected in a clockwise rotation, we say this is an R enantiomer. So like these examples here, this would be an S enantiomer because it's rotating in a counterclockwise direction, and this would be an R enantiomer because it is rotating in a clockwise direction. An example that I have for this problem is an example from our practice exam, and it says which of the following molecules are assigned to R. So for the first one, we name priority on each of the different groups, and then we put H in the back, and we look at priority groups 1, 2, and 3 face towards you. And if we connect 1 to 2 to 3, we can tell that this is in a clockwise direction, so it is an R enantiomer. The opposite would be K, example K right here, where if we put H in the back and we start with the highest priority group of fluorine, we go from 1 to 2 to 3 in a counterclockwise direction, which would be an S enantiomer. And this is the same for example L right here. This is an S enantiomer as well if we put H in the back. And then lastly for M, H is already in the back, so this example is easy, so we can just look at these groups and we can see that it goes from 1 to 2 to 3, which is a clockwise direction, so it is an R enantiomer. So this makes the answer J and M, as we can see stated below. Thank you.